Two compounds of barium are barium sulfide and barium chloride. The hazard symbol shown in figure 2 is on bottles containing barium metal. State the meaning of this. Obviously it's flammable, no point going into much detail there. Give the names of the elements combined in barium sulfide. So if, just one thing to be aware of, obviously it's barium, so you get the metal first, barium, and you get, it says sulfide. Now if it said sulfate, then it would be sulfur and oxygen. Things which end with 8 contain oxygen, but this is sulfide. That means sulfur is by itself, but we don't call it barium sulfur. Whenever the non-metal reacts with the metal in the compound, we change the end to IDE, like chlorine becomes chloride, fluorine becomes fluoride, sulfur becomes sulfide. So we just get two elements here, barium and sulfur. Barium is chloride is toxic. Explain one safety precaution that should be taken when using barium chloride. So think of anything when you're dealing with a poisonous substance. Wear gloves to protect hands, wear goggles to protect eyes. Basically, normally, if you're stuck, safety precautions with chemicals, you often get the marks just for talking about gloves and goggles. So when stuck, just when in doubt, just go to these. And if it says explain, then you have to give a reason for why you need those. If it said describe, you just say wear gloves. If it said state, you just say wear gloves. But explain, you have to say what you'd wear and why you do it. So obviously gloves to protect hands, goggles to protect eyes. You could also say with a toxic substance, use a fume cupboard to avoid inhaling any dangerous fumes if it's, if it vaporizes. Right, next. A beaker of barium chloride solution and a beaker of dilute sulfuric acid were placed on a balance as shown in figure 3. So you see dilute sulfuric acid and barium chloride. The total mass reading on the balance was 25.7 grams. The dilute sulfuric acid was poured into the barium chloride solution and the beaker replaced on the balance as shown in figure 4. The mixture contained a white precipitate. State the total mass reading on the balance after this reaction. So whenever you see a question which is normally worth 1 mark in chemistry, and they give you a starting mass and then a reaction happens and you have to say the new mass, it's almost definitely going to be the same mass in the question because they're testing you that you understand the law of conservation of mass. So what chemicals you start off with, they may be in different form. The atoms that make them up may be in a different arrangement when they react, but the same number of atoms are present. We're not making new atoms or destroying atoms. So we get the same, because there's the same number of atoms, we get the same mass. The only reason this mass would decrease or increase, it would decrease if a gas is produced and basically atoms are escaping, or the reaction, which often you'd require heating for, causes gases or oxygen atoms or something to react with whatever is in there. So you're adding atoms in. But then you wouldn't need to write the mass down because there's no way you could guess how much is going and how much is coming in. So you're almost certainly going to have to recall the same mass. And it's only 1 mark. So remember, look out for these 1 mark mass questions. Really easy. Give the name of the white precipitate formed by the reaction of barium chloride solution with dilute sulfuric acid. Well, when you react a metal compound with acid, the new compound, because all you have to understand is a new compound's made. Yeah, it might be a white solid. A precipitate is just something which becomes undissolved in solution. So, for example, let's say this was your original solution. Once it forms a precipitate, you'll actually see something there. Something's come out of the solution. It's precipitated out, and it'll normally settle at the bottom. So, give the name. You take the name of the metal, and then you listen to the sound of the acid which it's reacting. So sulfuric acid will form metal sulfates, nitric acid will form metal nitrates, and hydrochloric acid will form metal chlorides. So we're dealing with sulfuric acid, so the answer would be barium sulfate. That is what the answer would be. You don't need to write all this down, I'm just showing you the chemical reaction. So barium reacts with sulfuric acid and the name carries forward. Sulfuric becomes sulfate, barium sulfate, and what you're left with is hydrochloric acid. But this is the important part. Barium sulfuric acid becomes barium sulfate. Sodium or solid sodium chloride is dissolved in water. the sodium chloride solution is electrolyzed in the apparatus shown in figure 5. So we can see we've got an electrolysis set up. We've got a direct current because electrolysis only works when the current flows in one direction, not an alternating current where it goes back and forth. We've got the negative end of the terminal attached to a electrode here, and it's made this the negative electrode, which we call the cathode. If you forget, just think of a catty negative attitude cathode. And over here, positive, the positive terminal will create an anode, a positively charged electrode. Now, it says state-wise sodium chloride solution rather than solid sodium chloride must be used in this experiment. So you have to understand that an electric current is a flow of charge. So charged particles like electrons and positively charged and negatively charged ions, if they're moving, they will conduct electricity. But in a solid form, in a giant ionic lattice, you have these charged ions. You have positive ions, which we call cations, and we have negative ions, which are called anions. Cations because they're attracted to the cathode, anions because they're attracted to the anode. But in a solid state, they're fixed in position. They can't flow. And because of that, they can't carry an electric current. But when they're dissolved or melted, then they're separated. The ions are separated and they're free to move. And then they can conduct an electric current. So state, so just say state. You don't have to explain anything. Why sodium chloride in a solid state will not work, but will when it's in solution. Quite simply, you just say ions are free to move in solution. That's it, they're free to move. It's a very popular question. The formulae for the ions present in sodium chloride are Na+, that's a positively charged ion, chloride Cl-, H+, and OH-. Circle the ions that would be attracted to the anode. So if you remember, the anode has a positive charge. So opposites attract in chemistry. So chloride ions will be attracted to the positive charge and hydroxide ions will be attracted. So any minus charge will be attracted. Next, molten lead bromide can be electrolyzed to form molten lead and bromine gas. So in other words, we can get a melted version of the ionic compound lead bromide. And when you electrolyze them, you get lead forming at one end and you get bromine gas forming at the other. Metals always form at the cathode because they're positively charged ions and the cathode is negative, catty attitude, negative. And the non-metal part, the gases, they will form the positive anode, the positive electrode of the anode. So explain how a student could modify the apparatus shown in figure 5 to carry out this electrolysis. Well, if we look here, they've just got a glass beaker. They've made a point of it. And if we're trying to melt something with a very high melting point, because all ionic compounds have very high melting points because of their structure, this structure with the strong electrostatic forces of attraction, we need something more appropriate than a glass beaker. We need either a metal can or we need a crucible. That'd be a good thing, a crucible. And then obviously we need a heat source to melt it. So we need something which is heat proof, which won't break under high levels of heat when subjected to high levels of heat, and we need a Bunsen burner flame or a heat source to actually melt the lead bromide. So remember, this question said explain how a student could modify the apparatus shown in figure 5. Explain. So you have to say what the change would be and why. So firstly, use a metal container or crucible. That's what this is here. This is a crucible, which will not break when heated. That's the explanation. And then add a Bunsen burner. That's what we change to provide heat to melt the lead bromide. Any one of these would get you 2 marks. You don't have to mention all of them.